Hello everyone, I'm Willem Zohar and I will be presenting our paper on machine translation quality estimation, which is a collaborative effort with multiple co-authors and proofreaders. This video won't go into details of the paper, but motivates the problem at hand. I hope that afterwards you'll be excited to read the paper on your own. We'll start by looking at what quality estimation is and why it's important. Then we'll explore how it solves the problem of data scarcity and how it relates to human judgment and automated metrics. And finally, we'll discuss the broader perspective of quality estimation. Skipping over an ocean of nuances for the sake of time, quality estimation is a function that judges how good a translation is without the reference. It takes in a source sentence, for example in German, and your translation in English. And here's an example of translation error that it could catch, namely happy pizza. From an industry and user perspective, quality estimation is crucial. Nowadays, translation companies rely heavily on first drafts by machine translation systems, and QE helps estimate the planning, costs, and distribution of translators. From the translator perspective, it is beneficial to know if the translation draft is correct or not in order to judge how much attention it needs. If a translation is marked as 100% correct, then it likely can be only skimmed. Finally, from the user perspective, when working with an online MT system, it is useful to know if the translation is correct or not and where possible mistakes may be. When evaluating the translation quality, we usually use humans. Give them the source, the hypothesis, and possibly a reference, and they will read it and provide some evaluation, in this case a number. However, humans are expensive and neither scalable nor easily reproducible, so we turn to automatic metrics, which are functions or models that try to produce numbers which correlate well with humans. In production setting, we don't have access to the reference because we are trying to create this reference, so we have to do the same task as automated metrics, but without the reference. Our task is to find a function that correlates well with humans. If we allow the reference, we have the standard metric, and one way to go about finding the function f is to just really think hard about what it means for translation to be good. And people have done that and came up with lots of different metrics, such as BLE or character level F-score. However, another approach is to also learn the metric from data. That is to minimize the difference between the model prediction and actual human scores. Now there are some issues with that. Most data can be sourced from WMT, which collects a lot of evaluation points every year. It is constrained to specific high-resource languages, and if you want to have a QE system between Amharic and Bengali, you are out of luck. Similarly, WMT is still very news domain-oriented, and the idea of what quality is depends on the domain and application. In legal translation, you maybe don't care that much about style, but want to get your reference as well. In contrast, in subtitle translation, you have other stuff to care about, such as segment alignment. This all points to there not being a silver bullet for QE, and just training it on WMT misses a lot of nuances in what we actually need in applications. In those cases, you'll have to crowdsource your own human annotations, which is expensive. To tackle this issue, we can use reference-based metrics that aim to correlate well with human evaluations. And then we first train our quality estimation function to first predict these metrics, and then fine-tune the model on the human data. Our paper focuses on predicting reference-based metrics without the reference, and we measure the success by segment-level person correlation, and our results show that we can model BLE with about 60% person correlation, which is non-trivial given that we don't have access to the reference. However, our task is not to model the metric, but the human evaluation. When we fine-tune our model on human data, we see that it outperforms the baseline, which is training only on the small human data. We are also interested in model mismatch, which is when we train our model estimation system to predict errors of one machine translation model and then apply it to a different one. And our results show that the metric estimation models are still effective even when applied to a different MT model. And that is, there is only a small drop in performance compared to training the estimator on the target system. Now, we started this work by asking the question if metrics can be estimated without access to all the variables, specifically to the reference. However, we can go further. We can ask if we can estimate the metric without seeing the source or the hypothesis. And this may all seem a bit far-fetched, but it makes sense to try to estimate the metric just based on the fluency of the sentence, which is unlikely to be a good translation of anything. Or if a sentence is complex, it is very likely that any translation is going to be faulty in some way. In conclusion, quality estimation is crucial for the industry and users alike. And our approach shows that we can predict reference-based metrics without access to the reference, which can be especially useful when working with low-resource languages. There are several follow-up questions. I would be excited if the same approach was adapted also in other NLP tasks where human annotation is costly, but where reasonable metrics exist, which could be used in pre-training. Thank you for listening to my presentation, and don't hesitate to contact me for follow-up discussions of the paper and new ideas.